Dear colleagues, I'm honored to have this opportunity to present the research findings on behalf of our team. I'm Cai Degou from China Academy of Railway Sciences. Today, I will present the vibration compaction characteristics and compaction effect evaluation method of high-speed railway subgrade. First, introduction. As we know, subgrade is very important infrastructure of high-speed railway, which bears the load of track and the train. The dynamic deformation of control standard of subgrade structure reaches millimeter level, which puts forward high requirements for subgrade feeling quality. The detection area ratio of the traditional subgrade compaction quality control, such as K30, EV2, EVD, K-spot detection methods, is only 10,000th, which cannot fully reflect the compaction quality of the rolling surface, and the detection time counts for 1/3 to a half of the construction period. Therefore, Tuna analyzed the deformation degree of the acceleration signal of the vibrating wheel in 1980, which can express the soil stiffness in a certain extent. He proposed to use the ratio of the second harmonic amplitude to the first harmonic as the index to evaluate the soil stiffness, and defined this index as the compaction meter value, or CMV. China high-speed railway subgrade is mainly filled with coarse-grained soil. The particle size gradation, feeding thickness, and subgrade structure are significantly different from highways and dams. Besides, the components of vibration response spectrum of coarse-grained soil are complex, and the detection accuracy and reliability of existing continuous detection indexes are low because China high-speed railway subgrade is mainly filled with coarse-grained soil. Therefore, in view of coarse-grained soil filler of high-speed railway in China, it is necessary to develop a new continuous compaction evaluation method, ensure the construction of high-quality railway subgrade. The second part is to introduce continuous compaction control index, compaction energy value, which referred to as the CEV. The compaction energy generated by the vibration of the drum propagates to the feeding material of subgrade in the form of waves. Part of the energy is absorbed by the feeding material of subgrade, and the other part is returned to the drum. How to calculate the CEV index? In order to quantify the amount of energy carried by the nonlinear vibration signal, the acceleration signal of the drum is decomposed by the EMD. The energy distribution is displayed in the form of a marginal spectrum in each frequency band of the vibration signal. The physical meaning of the marginal spectrum is the total energy of the instantaneous frequency in the signal. It can be used as a continuous compaction control indicator to determine the degree of compaction of the feeding material of subgrade, which uses the principle of integration to sum the marginal spectrum curves to obtain the total energy carried by the vibration signal. The frequency band of the energy carried by the vibration signal of the drum gradually expands with the increase of the number of compaction passes, which is concentrated in the frequency band corresponding to the fundamental wave, and the first harmonic gradually expands to 0 to 100 Hz. The frequency band of the energy carried by the vibration signal in the feeding material of subgrade varies little, and the energy corresponding to the fundamental wave gradually increases. Moreover, the energy changes corresponding to the fundamental wave are different, and the total energy of the drum and the feeding material of subgrade is gradually increasing and becomes stable after the feeding material of subgrade enters a relatively stable and dense state. It reflects the effectiveness of energy detection in compaction process by CEV. The third part is the field test. The verification of the continuous compaction index is carried out by establishing the correlation between it and the conventional detection method, and the correlation coefficient meets the requirements of relevant specifications, and the index has a strong correlation with EVD, which can be used to reflect the continuous compaction process of the subgrade. The correlation coefficient of CEV and CMV index is 0.87 and 0.61, which meet the requirements of the Swedish compaction specification. What's more, the CEV correlation coefficients with K, K30, and EVD are 14 to 25% higher than those of CMV, and the accuracy of continuous detection of compaction quality of coarse-grained soil filler for high-speed railway subgrade is greatly improved as shown in the figure. Besides, the continuous detection technology of compaction quality has been successfully applied to more than 20 lines, such as Beijing to Shenyang, Zhengzhou to Wanzhou, and Beijing to Zhangjiakou, with an application volume of about 25 million cubic meters. And compared with the traditional filling process, the cost is saved by more than 10%, and the social and economic benefits are remarkable. The last part is the conclusions. Through the above research analysis, we have drawn the following conclusions. The Continuous Compaction Control Index, or CEV, of high-speed railway subgrade, based on vibration signal energy, analyzes the characteristics of energy changes during the compaction process according to the law of conservation of energy. The change characteristics of the energy carried by the vibration signal of the drum are used to reflect the energy exchange during the entire compaction process, and the energy is quantified in the form of the marginal spectrum of the vibration signal. The correlation between the CEV index and the dynamic deformation modulus EVD was established in the field test and compared with the CMV index for verification. The correlation coefficients of the CEV index are greater than the CMV index and has been successfully applied. Thank you for your attention.